Paper of the day is the Cascades framework for query optimization. This paper describes a new extensible query optimization framework that resolves many of the shortcomings of the Exodus and Volcano optimizer generators. In addition to extensibility, dynamic programming, and memorization based on the extended from the Exodus and Volcano prototypes, this new optimizer provides manipulation of operator arguments using rules or functions, operators that are both logical and physical for predicates, schema-specific rules for materialized views, rules to insert enforcers or glue operators, rule-specific guidance permitting groupings of rules, basic facilities that will later permit parallel search, partially ordered cost measures and dynamic plans, an extensive tracing support, and a clean interface and implementation making full use of abstraction mechanisms of C++. They describe and justify their design choices for each of these issues. The optimizer system described here is operational and will serve as the foundation for a new query optimizers in Tandem's non-stop SQL product and in Microsoft SQL Server product. Now let's look at the Cascade highlights. Compared to the Volcano design and implementation, the new Cascades optimizer has the following advantages. In their entirety, they present a substantial improvement over their own earlier work as well as other related working functionality, ease of use, and robustness. The first of these highlights is abstract interface classes defining the DBI optimizer interface and permitting DBI-defined subclass hierarchies. Second, rules as objects. Third, facilities for schema and event query-specific rules. And then we have simple rules requiring minimal DBI support, and then rules with substitutes consisting of a complex expression. Rules that map on input pattern on a DBI supplied function. Rules to place property enforcers such as sort operations. Operators that may be both logical and physical, example predicates, pattern that match an entire subtree predicate, example predicates, optimization task as data structures, incremental enumeration of equivalent logical expressions, guided or exhaustive search, ordering of moves by promise, rule-specific guidance, and incremental improvement of estimated logical properties. The Cascade optimizer was designed to be reasonably fast, although extensibility was a more important design goal. Among the artifacts of separating the optimizer framework and the DPI's specification of operators, cost functions, and etc. are extensive use of virtual methods, a very large number of references between structures, and a very frequent object allocation and deallocation. While unavoidable, there probably is room for improvement. In particular, if one is willing to give up a strong separation that permits modifications of DPI code without recompiling Cascades code. Before this demodularization step is taken, however, a strong argument should be made based on the measurement study that would indeed improve an optimizer's performance. Now, let's look at the conclusion. Beyond a better and more robust implementation that found in the Exodus and Volcano optimizer generators, the Cascade optimizer offers a number of advantages without giving up modularity, extensibility, dynamic programming, and memorization explored in early prototypes. First, predicates and other item operations can conveniently model as part of the query and plan algebra. Operators that are both logical and physical, thus it is easy to specify operators that may appear both in the optimizer input and in its output. Function rules and the tree operator permit direct manipulation or even complex trees of item operations using DPI supplied functions. Second, enforcers such as sorting are normal operators in all ways. In particular, they are inserted into a plan based on explicit rules. In Volcano, there were special operators that did not appear in any rule. Third, both exploration and optimization can be guided and controlled by the DPI. Together with the more robust implementation as required for the industrial deployment, they believe that the Cascades optimizer represents a substantial improvement over earlier extensible database query optimizers. Now let's give this paper a PS score. Overall, this paper is a rough read, so it gets 5 out of 10 on readability. 10 pages long, it scores 6 out of 10 on length. It's a research prototype with average description, so that makes it 6 out of 10. Its industry value and learning meter is decent, so it gets 6 out of 10 on each. Overall PS score is 6 out of 10.